We can classify electrical conductivity based on three types of conductors. They are good conductor, bad conductor, and semiconductor. A good conductor, best example is copper wire used at home power supply wires. For bad conductor or insulator, best example is plastic which will not conduct electricity. For semiconductor, the best example is silicon which will conduct under certain conditions like giving more voltage or adding some extra component to silicon. Let kids identify some more types of conductors and don't forget to add points to the enthusiastic group. When it comes to the story of electronics, the three main characters that control the world of electronics are voltage, current, and resistor. Let's start the story with an activity called passing the chits. Take some handful of blue chits and let the negative volunteer have it, and positive volunteer will have equal number of red chits. Pass the chits from negative to positive side. When all the chits are passed, then it means the battery is drained fully. Distance between negative and positive volunteer should be large that both cannot pass chits between them. This activity could be more fun if there is a timer volunteer to monitor the time taken to traverse the chits. Next, make sure distance between two kids should be large that both cannot pass chits between them. Note above that between the kit they are not reachable. This explains open circuit. Next, with a resistor volunteer, note the R volunteer. He or she should receive chits coming from negative volunteer via kits acting as conductor and send it slowly. That is, if R receives two chits, then give one chit towards the positive. The same way, explain about increasing resistance and become insulator where you don't give chits towards positive side. Outcome of passing the chits activities are: learn electron flow from negative to positive terminal, learn about open and closed circuit, learn about resistor's role in a circuit. Voltage is nothing but the potential difference between two charges or 2 points in a circuit that is connected to a power source. The measurement is done in volts, example 5 volt or 230 volt. Current is the flow of electrons that result from the force produced by voltage. Always current flow from higher potential to lower potential. It is measured in ampere, example 1 ampere, 2 ampere, etc. There are two different types of current. They are direct current and alternating current. Direct current are seen in batteries and alternating current are seen in our normal home power supplies. The reason why AC is used for home power and not battery is that long distance transmission is possible only with AC as the losses are less. Direction of current flow is shown for DC and AC, where for DC the flow of electrons is on side, that is from positive to negative terminal. In case of AC, the terminals swap their positions very frequently, making the electron flow move to and fro. Here we will look into the working of basic electronic components and their functionality. Resistors are used to limit the flow of current in a circuit. Resistors are available in various values which are typically measured in ohms. There are fixed and variable type of resistors. In variable type of resistors, there will be a slider or screw to change the resistance value. In the above example, battery is connected to LED with a resistor to make sure that the full current from battery does not damage the LED. PHET simulations practical. Laptops are needed. Download the jar files for the simulations from the locations that are given in the slides. Let the kids do the simulations by themselves using secondary volunteers' help. Arduino board will be fixed with Arduino Shield and its top and bottom view are shown. If you see the breadboard predefined connections, all the yellow and violet horizontal lines are connected individually. Vertically, there are no connections. Get the inventories ready as shown in the requirements and let kids know how to connect components in breadboard. After they connect, secondary volunteer need to check how they have connected, then give power source. LED glow 1 resistor. To do: LED should glow. So the story ends like voltage will push the electrons to produce current, but resistor will always try to stop electrons. So we can come up with a relation like I, that is current, which is directly proportional to V, that is voltage, and inversely proportional to R, which is resistance. Capacitor can be compared as a battery in terms of operation. It is made up of two metal plates with an insulator or bad conductor in between the plates. This makes the charge stored between the plates to stay, as charges in both plates try to neutralize but will not happen so easily due to insulator in between. But when the two plates are shorted with a conductor wire externally, then the discharge will happen and neutralize. Capacitance is measured in farad, so a battery can be compared to a capacitor with very high value of farad, so it holds charge for a long time. But in case of normal capacitor, it will hold few seconds, for milliseconds or even microseconds, depending on the farad value. Capacitors are available in various shapes and materials as shown above. Diode is a device that will allow current in one direction and won't allow on other side. It has two terminals, anode or positive terminal and cathode or negative terminal. When anode of diode connected to positive of battery and cathode to negative of battery, then the diode acts as a conductor. If reversed, it will become insulator. Transistor is the most important device for electronics, and its basic purpose is two things. One is to act as a switch, and next is to amplify the signals. Due to its feature to amplify signals, it is used in radio and phones to amplify the low signals to high signals, that is reproduced through speaker. As shown in above diagram, the small water pipe is used to control the large water pipe. The same way, small current is used to control high current in circuit, thus showing the concept of amplification. We have studied on the components of electronics, but nothing will work without connecting them, and for that we need to study the type of connection, namely series and parallel connection. This activity will teach the concept. As you can see, there are two parts in this. Step 1. Pass chits from negative volunteer to positive volunteer, one chit at a time, via 5 kits arranged as shown. Do the same with another set of kits in parallel, that is in step 2. Pass one chit to each line simultaneously so that positive volunteer receives 2 chits at a time. Outcome of series and parallel activity. Learn that parallel circuit gives extra path to connect so that if one line breaks, another line is there for backup. Learn about possibility to increase electron flow over parallel path. In case of series connection, if one device in circuit fails, then the other device in circuit won't work. But in case of parallel connection, the other devices are not impacted if one device fails as shown above.